Hi everybody, and welcome back to the next installment in an Astronomer Critiques creation. And in this episode, what we want to do is look at the next encounter between Ham and Nye on the Ark. There's also something I want to go back and mention explicitly about the Haven debate. And I also want to correct and critique a couple of things that I said in the last Haven video regarding quasars. I used some slightly sloppy language, and I want to clear that up and be a little bit more precise. So you could almost label this video an Astronomer Critiques creation and himself. So with that being said, let's go ahead and dig in to, oh, I need to rewind this. Let's go right here.
The Earth are the records of ice ages, the records of when unleaded gas was introduced by looking at the layers of snow. Mr. Ham, with respect, you completely misunderstand the point that you're trying to make.
No, Bill, I think you misunderstand the point. The point is, we actually know how long those layers took to be laid down. When you go and look at the layers of ice, when you bring up ice cores, you didn't see them being laid down. You weren't there at the beginning, and you make assumptions about the layers.
So you believe that there was a supernatural process that created the many layers that we observed, 670,000. No, but is that right? You believe that there was a supernatural process that created 670,000 layers?
Absolutely not.
How did it happen?
They were laid down catastrophically. They were laid down quickly. They didn't take.
There were.
In other words, when you make interpretations about each layer and how long it took to be laid down, that's your interpretation. And what we're saying is you can have multiple layers very, very quickly.
So
and we've seen
sounds
that in
like
the present.
Notice a couple of things that Ham has said here. First of all, he's telling Bill that he is blatantly wrong, and that what Bill is saying about the ice cores is an interpretation, but not admitting that his view is an interpretation by itself. When people are not willing to have their own logic applied to their arguments, that generally is a sign of arrogance and hubris. And when you dig into the core philosophy of creationism, I don't know how to describe it other than as politely as I can, as Bill says, with respect, that it's rife with hubris. And there's nothing, I don't think, that anybody like Bill could say that would change Ken's mind. But it wasn't to talk to Ken that Bill went to the Ark. It was for the conversations that are about to happen with the people that were there. And I shouldn't say that. I should say that I suspect that is why Bill went to the Ark. I haven't talked to Bill, so I don't know for sure what his exact motives were, but I suspect, being the educator that he is, it was to potentially interact with people touring the Ark and perhaps have conversations. But I don't know for 100% sure.
Sounds like you're cherry picking data.
No, I'm not cherry picking. That's just a good example. It's a great example.
Your claim is that there were 670,000 layers of snow laid down in, for example, Antarctica or Greenland or Boston.
Hey, look, you can get multiple layers in a day.
How many can you get in a day?
You can get multiple layers in a day, correct? I mean,
No.
you see.
No,
Yes, you can.
no, sir.
Yeah.
No.
You can
I
observe
challenge you on that.
You can observe that. Let me ask a question. All these young people here, you say if they're taught creation, it'll undermine technology, destroy technology, it'll destroy their science. Is that correct?
When you say destroy, you mean make Facebook not work? What do you mean?
Well, I'm asking you what you mean when you were at the debate and you said when you teach young people, children, you're going to have a major when you teach young people, teach children creation, you're going to have a major problem in regard to technology and advances in technology.
Who wants to be an astronaut? Anybody? And we find right on. Do you know we got a spacecraft in orbit around Jupiter on July 4th? How could it be? So I was at Cape Canaveral, you guys, on August 5th, 2011. Here, let's move away from the sound. On August 5th, 2011, I was at Cape Canaveral. We launched a rocket that went out beyond the orbit of Mars, fell back toward the sun, went around the Earth, where it took an infinitesimal amount of energy from the Earth's orbit, then went out to Jupiter and approached Jupiter from the north.
That's great observational
On Monday,
science.
That spacecraft went in orbit around Jupiter.
Once again, one of the reasons this debate is so hard to watch is the interrupting. To be fair, it is on both sides, but it's throughout the entire interaction, and it can be a little bit difficult. But notice what Ken said, right? He said a great example of observational science. Once again, drawing attention to this fallacious distinction between historical and observational science.
That's rocket science, everybody.
Yeah, and scientists, engineers in the present use their 5 senses to be able to develop that technology. What's that got to do with origins?
The same process enables us to count layers of snow.
No, it doesn't,
Antarctica.
because you're experimenting with the rockets in the present, the fuel, the structure of the rocket, the engineering. When it comes to looking at the layers that are already there, you weren't there to see them being laid down.
You weren't there to see them laid down. Neither were you, Ken. And you can claim that you have an authoritative explanation for it, but the thing that particular claim entails from a philosophical point of view means that you have to show and demonstrate philosophically that the Bible is, as you're interpreting it, number one, that the Bible is true, and number two, that your interpretation is true. And we know that, several, if not the majority, of theologians in the Christian, Judeo-Christian, Jewish faiths don't agree with this specific interpretation. So it's a rather large hill to make that statement stick from a logical point of view. And again, he's telling Bill that he wasn't there, so he can't see, so he cannot even use inference when he has to make at least 2 assumptive leaps. Even though I agree with what Bill's going to say, that Ken accuses Bill of making assumptions when it comes to these ice cores, but and Bill pushes back on that and says no, they're not assumptions, they're discoveries. I would agree with Bill that they're not assumptions, in that we have tested as much as we can that ice cores, or that layers of ice are cyclic by the year. And when you dig up the ice cores, you can then actually count the layers, and those represent cycles that the Earth has gone through yearly. At least over the short geological term. So, you can count back at least hundreds of years, counting the layers, and using radiometric dating, you can get back even further. Ken absolutely, insists that these are assumptions. But the reason he wants to call them assumptions, honestly, is only because they don't fit his view. I don't have another explanation, because they're not assumptions in the untested premise sense. So it's the thing that Ken is trying to call assumptions, that Bill is referencing, is not a random, untested guess. These are things that we have done several times and looked at and have gotten consistent results over the time spans that we know for sure the layers had been laid down, and therefore the extrapolation is as sound as it can be. At least the idea that you can extrapolate, and so it's not like this is an assumption where I just wake up one morning and go, oh, I think I'm going to define a layer in an ice core to be this thick, and for every thickness that I have, I'm going to count that as a year. That's not what happens when we work with these ice cores, and that's exactly what Ken makes it sound like is happening, and it completely misses the mark of how science is done. Very little science, in truth. Very little scientific conclusion. Let me put it that way. Very little scientific conclusion would fit the definition of Ken's observational science. And on top of that, he doesn't even define what observational science is. Cell phone technologies incorporate principles from quantum mechanics, but we can't see individual particles, and we can't see wave functions, and we can't see the probability distributions that the wave functions represent. So when you use a cell phone, is that observational science? Because you're observing the effects of what you think is happening and what you predicted should happen, even though you can't see the individual constituents? Or does observational science demand that you can actually see what you're doing? And in the original debate, I don't think that this was clearly described. So I would push back very heavily and say, what do you mean by observational science? What do you mean by historical science? And why the insistence that these two are distinct? Why the insistence that they have to be treated as two separate things? For practicing scientists, if you're following the scientific method, then what you're doing is science. It doesn't matter if you're trying to understand something about the past, as in an evolutionary biologist or a geologist or a climatologist or a paleontologist, or if you're doing something in the present with atomic nuclei in the lab, as a physicist might, or as a physical chemist might. We don't make that distinction. It just doesn't exist in the practicing sense.
That's the point.
Yeah, so how do you feel about forensics, Mr. Ham? How do you feel about the process that detectives use to determine what happened at a crime scene?
Oh, yeah.
If you weren't there and you didn't see how a guy got killed.
And they have to interpret the evidence, and sometimes they get it wrong, actually. And those things are much closer in the present than when you're talking about way in the past, because it might have been a murder that happened yesterday, and so yeah, you can go in and look at the evidence.
So you're saying,
but scientists have been known, forensic scientists have put people in jail who've been innocent, correct?
I suppose, yeah.
Because they made the wrong interpretation.
But they've
they didn't have
also
all the
arrested a
evidence.
lot of people based on very good science.
Yeah, based on science in the present. In other words, you can test for blood and say, this is blood.
So this is where we disagree. Everybody, this is where we disagree. This is where Mr. Ham and I disagree. On the nature of evidence.
Oh no, the evidence is all the same. It's not
So
the nature of
when
evidence.
Bill is trying to drive home a very important point here. And Ken is trying to defend his position that the evidence is the evidence. What Bill is trying to say, and I'll let him say it in a minute, is that how you allow yourself to draw conclusions from evidence is different between these two worldviews.
Find people on the outside.
It's the nature of
Find layers of
Bill.
snow that are this thick because they're crushed down by 670,000 years of snow. We interpret it as real. The snow actually fell 670,000 years ago. The number of neutrons.
Where's the label saying it's 670,000?
The neutrons.
I don't want you leading.
Again, with the labels, this is not how science works, and it's almost farcical for someone supposedly as educated as Ham is with science to demand this. They don't demand anything of a similar nature of their own. It's baffling at a level that is frankly frustrating. Only because the people like him who perpetrate this should know better. And the only reason I say that is because they ought to know the difference between the scientific method and pseudoscience. And this is something that practicing scientists wrestle with all the time, especially in the internet day and age. How to combat the growing culture of pseudoscience. If something looks like it's science, if it smells like it's science, then is it science? And oftentimes, no, it's not. If it only kind of looks like science and it kind of smells like science, it's probably not actually science. And we in our culture don't have a robust education on what the scientific method really looks like in practice. So this caused some problems, okay? Especially in the COVID pandemic. It allowed people to make some really bad conclusions, and draw some really bad conclusions. And it was because it's this very thing where we have the lack of science education, where people think they knew how to properly critique scientists, or they think they knew how to properly draw scientific conclusions, and in some cases with extremely disastrous results. And so my argument is we need to be able to place science in its proper context and allow a robust education in science in our schools, and not just science facts, not just what the difference between a leaf and the trunk of a tree are, or the difference between a squirrel and a mongoose, or the number of bones in the body, and those types of things. As important as those things are, what we also need to seriously focus on in our science classes is how science is done, how to evaluate a scientific claim. And the reason that we can say with some degree of confidence that we need this is because the only reason we have technology, we have vaccines, we have the internet, all of this came about because of science. And so when you undermine the scientific method, you take away and disempower people from achieving technological advancement. And does this mean that all technology is good? No. But if we keep an ethical head along with our technological acumen, we can build things for the general good, and that's what we should be doing. A lot of medical advancement has been achieved in that manner, and so it's just baffling for people to perpetuate what is demonstrably assumptions when they're attacking assumptions.
Leading these young people astray. Where's the label saying it was 670,000 years?
And in the layers themselves.
How would they see 670,000 years?
You would count the layers. You would go to the Ice Core Lab in Golden, Colorado. We've been there. And you look at a block of ice that's been drilled out of the ice in Greenland.
And you count the layers, and what do you do with each layer? How do you get the 670?
That's how many thousands of layers there are in certain of the cores.
But what are you assuming about the layers? Was there one a year, or what are you assuming?
Sure.
But how do you know?
How do we know that? By careful measurement.
That's the very point of the example that we have here.
By careful measurement.
No, you can see
Furthermore, you can do this.
Some of these people are from states where they get massive snow and ice storms, and I've actually seen the layers in the snow. Have you seen the layers in the snow?
We're not talking about the same thing. Have you seen them crushed down to where they're clear?
When it rains on top of the snow, they do.
Yeah, but in Antarctica,
and multiple layers. And multiple layers.
So you guys, I want you to evaluate my.
So this is a really good example of a tactic that is often used where the phenomenon being discussed resembles something else. So therefore, I'm going to call these two things equivalent. What Ken references here, where people get a lot of snow and they can actually see the snow crushed down into the layers, and then the young lady responds with to Bill's question about, have you seen them when it's crushed down to when they're clear, and she said yes, when it rains. The process that Bill is talking about is much different than the process of rain making snow into an icy mixture that becomes clear. The snow that gets compacted at Antarctica, it gets compacted down as fresh layers keep falling during the precipitory months. that pressure builds and builds and builds on the lower layers, and so you get crushed until your density is such that the ice becomes essentially clear. So you can actually see the gradations through to the top layer in clarity along with the layers. And so you can, this is how sometimes the individual layers are defined. And then you use the radiometric dating to get corroborative dates. But what Bill is talking about with the neutrons is the ice, the conditions in the atmosphere are often going to get trapped in gases in the ice. And so these gases can interact with the water, and the water itself will then contain the information about what the climate was like when the that particular set of gases were captured in the ice. And so it's painstaking and it's difficult, but it is doable. And this is how we infer what the climate was like 100,000 years ago.
I claim that when there's 670,000 layers in a core of ice, there are 670,000 years associated with that.
Well, no,
Compare that.
You got to tell them
with
where you
his
get the years from. Where do you get the
Oh
years
no,
from?
I say they'll evaluate it for themselves. You don't have to take.
That is the best thing that any scientist can say. Go evaluate it for yourself. Science is built on using our senses to observe phenomena either through test or observation. And we don't want people to take our word for it. An ethical scientist never wants someone to take their word for it just because they said it. In my particular field of stellar astrophysics, pulsating variables, if I discover a new pulsating variable star, I don't want people to just believe me. I want my colleagues to take their telescopes and go look at the same star, look at the same comparison stars, and make the same measurement, and make sure I didn't do anything wrong. I want them to go see for themselves, and they want their friends to then go see for themselves, and so on. And this is what is fundamental to science. It's not about taking anybody's word for it. It is going and seeing for yourself.
Take my word for it.
Okay,
You're not taking the word.
have you seen layers for multiple layers?
Sure. I would like to know your opinion though. Like what are the years? Like what do you think they are? Is it every layer is one
So
year?
when you guys see these particular pieces of ice I'm talking about, and there's a building in Golden, Colorado, where we keep them. It's minus 36 Celsius. Everybody who works there puts on a big hood, big parka to go inside and work. You can see where the snow is crushed down. The tines of snowflakes break, release a tiny bit of heat, which makes it melt ever so slightly. And they turn this distinctive clear color. You can look at when unleaded gas was in use and when leaded gas was in use. You can see the chemicals in the snow. You can infer the temperature of the sea surface by the number of neutrons in the water. You evaluate my way of looking at it and compare it with his.
Well,
My way of looking at it is from the outside.
Here's what I want to do for the young people. I actually want to teach them how to think correctly. And that is, you have these layers in the present, and you weren't there to see them being laid down. You don't know how many storms there were. You don't know how many
But how would you
times there
figure
were-
out how many storms there were?
Ah, well, that's the point. That's it.
Well,
Chip
there's a
Hill,
way
that's
to do
exactly-
it.
That's it.
Ham said, I want people to think correctly. I want to teach people to think correctly. Which is basically, what basically Ham is saying is, you can't know it unless you can see it right now. And from a scientific point of view, that is absurd, because we know paleontologists can make predictions about societies in the past based on what we know about other societies in the past, and then they can go test those predictions. If you have an amenable case or a new discovery where you can test that prediction, and you can then evaluate your own, acumen. You can evaluate your own body of knowledge and revise your understanding. But these are tests that we can do. And astronomy uses past in time measurements. Paleontology, geology, biology, climatology, all of these different fields depend on looking back. And if you can't reliably say what was in the past and why something occurring in the past is related to a prediction that I can make and test right now, that's precisely why evolution is as robust as it is, because it has made predictions about the fossil record on top of making predictions about current mutations in bacteria, in viruses, and so on. And we can track these mutations very, very quickly because they happen. We have a new flu shot every single year because the flu virus or family of viruses mutate into new strains. And this happens very rapidly. And we can take the basic principle of natural selection and apply it to a wide variety of situations, including things that we can see right now, so we can observe in the present, and they happen. And so that helps bolster the fact that what we infer from the past should be accurate. It likely is true. When somebody makes a prediction about a find in the fossil record and then we go find it, corroborated with all of the current things that we see, it just builds a very strong picture. When we look at the mutations in DNA, you can exhume bodies from 100 years ago and look at DNA in different cultures, take samples in DNA now, look at how they've changed. And then you can go back 200 years and 300 years, and you keep doing that, and you can track how it changes. And then you can say, okay, based on the patterns that we see here, what should have happened in our DNA, or what should be some basic things in our DNA that were 500 and 600 years ago? And then you go look, and you see if you're correct or not. The idea that because you weren't there, you can't make any confident statements or predictions is simply bizarre.
It's exactly, no.
His way, which I understand comes from a scripture, right?
No.
Don't you think that there have been such fluctuating climates and stuff that it's hard to know?
But we infer that also. We figure that out also. That's our business.
It's everyone's guess then? Kind of everyone has a separate guess?
I wouldn't use the word guess. Everybody understands that on the outside, 97% at least of the world's scientists are very concerned about climate change. On the outside.
No, you just
caused by humans.
Hey, Bill, you just swapped subjects. Let's get
back
to
of a piece.
No,
we discovered ancient climates and what it used to be like by looking at these same cores of ice, these same pieces of ice.
But are you really discovering ancient climates, or are you just discovering what's there in the present and you're interpreting as ancient climates? It could have been different conditions in the 1 year.
Very, very skeptical. There's absolutely no way, in my view, that you could have that many conditions in 1 year.
When you compress the entire history of the Earth into 6,000 years or 10,000 years, whatever the case may be, you're forced to have a lot of things happen at a rapid rate. For example, one of the favorite words in creation science is the word kinds, which to this point I still have not seen a rigorous definition of. And it's a word that they insist on using, and when you use a word and insist that it must be used in a particular field or instance when no one else in that field uses it, that's a huge red flag scientifically. But according to the classical fundamentalist creationist viewpoint interpretation of Genesis, there were two kinds of animal on the ark. So there were two dogs on the ark, and then those two dogs went on to breed and create all of the species of dog that we have today. And maybe I shouldn't even use the word species. We have all of the different breeds of dog that we have today, including wolves, shepherds, labs, corgis, whatever breed you like. They all stemmed from that one pair of dogs on the ark. That requires an almost hyper evolution for an explosion of species to branch in several different ways all at once and then just stop. We don't observe this hyper changing today, dare I say hyper evolution today. We just don't see it, and for that many new breeds to come about that quickly, if it were natural processes and not guided by human intervention, in the case of breeding dogs, we should still see that today, or at least evidence of it, that we should see the explosion in species, and we should then see the tapering off of how the breeds change. And we simply don't see that. And so it's a wild, difficult claim to substantiate. We don't have any evidence of this, and Ken is trying to apply the same logic to these ice cores and saying, oh, but it could be this, it could be that, it could be blah blah blah. But we don't have actual physical evidence that the Earth went through cyclic processes that we are observing happen on the order of centuries and millennia right now. We don't have any evidence that those happened rapidly in these ice cores. All you have to do is understand, you dig the first few layers, and you can see the first few ice core layers. You can see the first few years. And so then you can go back. You don't have to go back 160,000 years. You can go back 500 years. Dig an ice core that's only 500 years old, or let me put it this way. Dig an ice core that only has 500 layers. And you will see the dawn of the industrial age in the gases, and you can count that back down to 150 years ago. And you go, okay, this is when we started emitting these gases, so 150 years, 150 layers. And then you can go back even further and say, okay, even if the oldest times are uncertain, if I can count back 150 years, then I can probably count back 200. And I can probably reasonably count back 500. And you look, and we don't have any massive, weird changes in our climate, rapid changes in our climate over short time scales. within the past few hundred years. We have no signatures of it. And so it's at that point where if the Earth is only 6,000 years old, if it's only 6,000 years old, 500 years ago is almost 1% the age. So this ice core would represent 1%. If things changed wildly in the past, why aren't they changing wildly now? Without invoking miracles, which is fine to do, but if you're going to do that, you're no longer doing science.
But nobody noticed. Mr. Ham, there are trees older than you believe the Earth is.
How do you know that?
Mr. Ham, because we count tree rings.
But
Mr. Ham, there are pyramids, there are human-built structures older than the stuff you are showing you.
Let's get back to the tree rings. We want these people to understand.
So what we all wonder about you.
No, let's get back to the tree rings.
Let's talk about tree rings.
Okay, let's get back to tree rings. So when you're counting those rings, you assume one growth period a year?
Most of the time.
How do you know that?
We've looked at a lot of trees.
Yeah, and we've actually seen trees that can
Millions
have multiple.
of trees.
We've actually seen trees that can have multiple growth rings here.
Have you seen trees that
depends
have
on
thousands of tree rings?
Oh yes, absolutely. And when you put them,
I mean really.
And we, of course, we've actually got.
So when you get out there, when you get out in the world, compare his claim to my claim. My claim is that you can count years from tree rings. You can infer
let me ask
how many plants were there.
In front of all these young...
The tree ring issue is very, very simple. All you have to do is go plant a tree. And plant 10 trees. And wait 2 years. And then cut the first one down. And count the number of tree rings. Count the third one down, or the second one down the third year, count the number of tree rings. Count the third one down the fourth year, count the number of tree rings, and so on. And you'll see that every year on average, there's one tree ring a year. And so even if you have certain cases where you have really thick tree rings in a given year, or you might get 2 tree rings in a year, when you get a tree that's maybe 150 years old, it doesn't really matter if it has added an extra layer here or there, an extra ring here or there. You're going to get to within less than 1% of its age, even if you include every single tree ring as a year. For example, let's say you count 150 tree rings, and and the tree's actually only 148 years old. There's 2 errant rings that have multiple rings in that year. So the tree is 148, and you count 150 tree rings. You're still below 2% off of the age of the tree. When talking about the age of the Earth, an uncertainty of 2% is certainly okay and acceptable. So then if you know or have record of when a specific tree was planted, and you cut it down and you count the tree rings inside, and you then come across a tree that has thousands of tree rings, the only inference that you can physically make based on the data is that that tree is thousands of years old. It's the only valid conclusion that you can come to, unless you know something else about that tree that no one else knows. But all else being equal, it's the only valid physical conclusion.
Okay, let me ask you this. Do you know...
Okay, let's move on.
No. Do you know 100% for sure that it was 1 ring a year? Do you know 100% for sure?
You're cherry-picking a data.
Do
you
you
can
know...
tell the difference between rings. Sometimes there's a wide ring, sometimes there's a narrow ring.
There can be. And you have to put...
Scientists who study this
trees
take that into
together,
account.
and you have to look at those...
You're working real hard,
and you assume where the
Mr.
rings
Ham.
overlap.
You're working very hard. Carry on. Lead on.
No.
Yes, sir.
You took all this time to study all this, and you don't believe, right, in God.
I didn't say that. I do not believe the Earth is 6,000 years old.
Okay.
That's a very different thing.
But you do believe...
God?
I just don't want to discuss that.
Okay.
I think it's distracting.
But you do believe...
We're talking about the claim that there was a worldwide flood and all the plants in the world were under salt water for a full year.
Well, hang on.
That there's a claim that somehow pyramids older than 6,000 years exist and were not washed away. That somehow there are 670,000 layers of ice from 670,000 years of snowfall, and nobody noticed.
Okay, you just
Is
made...
the only thing you go by are the dating of today? Because if that's...
We go by all of it, the pollen grains, the tree rings, the ice layers.
The tree
and
ring,
the other
tree rings are
fundamental
like
thing,
ice
everybody,
layers.
we have very accurate records of how much carbon dioxide people have put in the air.
Hey, you know what's interesting? I promised Bill to give him a walk through the ark, and he came up here and just tried to attack me.
Keep straight.
And attack.
So notice what Ken Ham is saying here. As Bill is talking, listen to what Ken.
The tree rings, the ice layers.
The tree
and
ring,
the other fundamental
like
thing,
ice
everybody,
layers.
we have very accurate records of how much carbon dioxide people have put in the air.
Hey, you know what's interesting? I promised Bill to give him a walk through the ark, and he came up here and just tried to attack me.
I promised Bill a walk through the ark, and he came up here and just tried to attack me. Criticism in good faith, as well as skepticism expressed, is not an attack. Good science knows that it must be critiqued or open to criticism. This is why we publish in journals. This is part of the peer review process. You get critiqued by a referee, a peer who hopefully is as much an expert in your field as you are, and they critique the absolute daylights out of your paper. And then when you release it, your colleagues are then free to talk about your paper, talk about your work, talk about it, how the mistakes you made, how it might be garbage, etc., etc., etc. Literally no criticism is off limits within the bounds of cordiality. Hopefully things stay cordial, not all the time do they, but no strength of language is off the table. If somebody thinks they have detected a serious flaw in your work, they might think that you're a good person, an okay person, but there's nothing restricting them from shredding your work. And they should, if they think they've detected a potential flaw or a fatal flaw that would bring your work down. There's no rules in science against criticism, and the fact that Ken is taking all of this as an attack instead of a conversation, which Bill is, I will give it to Bill, as interruptive as they both can be of each other. I will give it to Bill. He's trying to have a conversation, and that's what Ken is not understanding here. Bill is wanting to have a conversation. He's trying to have a conversation and engage the audience and Ken with challenges to the information that Ken is presenting at this ARC encounter. And all Ken sees is that Bill disagrees with him, so he takes it as an attack, not as, is this really what the evidence suggests?
keep straight
and
both
attack what we're doing
carbon
here.
dating, which goes back a few hundred and sometimes 1,000 or so years, with radioactive dating, which goes back billions of years.
So tree
go
rings,
ahead,
tree rings. You don't know it was one ring a year.
Sometimes it's a little different.
Okay, but you agree that it could be more than one ring a year because you could have more than one growth period a year. That's
that I don't know. I'm not an expert.
You can.
Okay, I'll take your word for it.
And when you're not an expert in something and you say, I don't know, that is a perfectly valid answer. It's a perfectly valid answer when you are an expert in a field. If you don't know, then you shouldn't, number one, say something intentionally just to have something to say and end up be wrong. It's one thing to make a mistake, and like I'm going to fix one of my mistakes here in a bit. It's one thing when you simply make a mistake. We all make mistakes. It's another thing when you intentionally say something that is false or something that is wrong. And we should try to avoid saying things intentionally that are wrong just so we don't sound ignorant. When you say I don't know, it can come off as ignorant, but it's actually one of the best responses anyone can have when they're not sure of something.
Climate's my thing right here, then I'll get out of your face.
I like it. Bring it on.
Well, no, you spend all this time, your adult life, researching all this and everything.
Yeah.
So why don't you just take the time, look at the creation that's here.
I have taken the time.
And God created that. He created man in his own image.
That could be, but I'm skeptical.
You're skeptical. Just take the time and have faith and spend the rest of your
Well,
life
see, here's the problem.
wondering about that.
No, here's the problem, you guys. As soon as you go back in time, as soon as you have any process of reasoning that requires a miracle, then it's not science. Then you departed from science.
Nail on the head. And this is the base argument for this entire video series I've been doing. And of course, Ken will jump in here and try to defend, but and if you listen to interviews from folks like Michio Kaku, who is the theoretical physicist at the City College of New York, he's okay with suggesting God, ghosts, miracles, etc. within the scientific realm if those also then turn out to be testable. If you can make a testable prediction, if you can say, okay, God, therefore this, and here's a testable prediction, then he's okay with that. And what Bill is saying here, Bill is using the word miracle in the sense of something that I cannot test, predict, or replicate reliably. And as soon as you do that, you are no longer in the realm of science.
Your belief doesn't require any miracles.
No miracle.
No miracles?
No.
So everything happened. No, everything happened by natural processes.
The other big problem that we disagree on.
So everything happened by natural processes,
yes,
right?
as far as we can tell.
So everything, the universe, all life happened by natural processes.
Well, see, we don't know. Here's another difference we have, I think.
Right.
When I find out that there was a Big Bang, Edwin Hubble discovered the stars moving apart from each other in 1927 or so. I go, that's astonishing, that's amazing. I am part of this universe, and yet I have the ability to understand this little bit of it. That's amazing.
Mr. Knight.
And hang on, let me finish this one paragraph. So when I find out that I don't know what there was before the Big Bang, or what it even means to ask the question, what was there before the Big Bang, I'm excited. That's fantastic. There's more to learn. There's another amazing discovery to be made.
Do you think you have
Whereas
a soul?
Other people are very troubled by that.
Do you think you have a soul?
Okay, let's walk down here.
Can I just ask?
Let's just walk down.
I can't tell. I don't know.
What if you miss it all?
I don't think I will. So I don't think I know.
Could I just say speculation? Pure
Please,
speculation.
yeah.
What would the evidence look like if there was a full Earth flood?
I don't know. I've never
hey,
seen it.
hey,
I've
Bill.
never seen anything like it.
We can speculate.
Bill,
I've never seen any
can I
evidence
ask
at all
you-
to suggest.
Can I ask you one question? Okay, you talk a lot, and that's great. But can I ask you one question that I really want to understand? If you promise you'll answer it.
Well, but I'm not going to necessarily give you an answer you want, yes or no, to tree rings and gears
I'm
and
not
stuff.
talking about that. In your worldview, when you die, what happens to you?
You're done.
You're done. So
And
what?
if that turns out not to be true, that would be very exciting.
Okay, but if you say you're done, so you won't even know you're ever here.
Apparently not.
So then, why do you care what we're doing here? Why do you care about climate change? Why do you ultimately? Because ultimately, when all these people die, they're done, and nothing has any ultimate purpose. So why does it matter? Why does it matter ultimately?
So let's be clear.
Okay.
What we do is make more people. What organisms do is reproduce.
But still, when they die, they're done. So why does it matter?
So my claim-
Why does it matter ultimately?
My claim is that not only your size and shape, number of fingers, eye color, and so on, is a result of the main idea in all of biology, evolution. Not only is evolution the main idea in biology, but what you feel is also a result of evolution.
But why does that matter if you're done when you die? I mean, why does it ultimately matter? Everyone's done. They won't even know they're here. Why?
You're asking fundamental existential questions. This is great, Mr. Hand.
But why?
The idea is to pass your genes on to the future.
But they're going to die and be done too. So
But
why?
they'll-
What Ken is doing here is demonstrating a failure to understand and comprehend what it is Bill is saying. And that failure is inhibiting the entire discussion. I would argue that it's a fundamental inhibition, and it has been a fundamental inhibition since they started discussing with one another. But Ken is asking Bill a question, and Bill is saying that, as far as we know from a naturalistic standpoint, the answer to what is the meaning of life is to pass on our genes for the next generation to be here and to inhabit the earth and to do good things. And that's not good enough for Ken. The problem is that we often try to impose the answer that we want. We try to tease that out of the person when we ask a question like this, but ultimately their answer, we have to let their answer stand as their answer. And Bill is saying the answer to what is the meaning of life, what is the ultimate purpose of life, is to pass on our genes. He's giving an explicit answer to the question. It's just not the answer that Ken wants. Because my guess is that Ken doesn't understand it. He doesn't understand that that is a valid response, that Bill is actually answering his question. Let's do just a little bit more, and then we'll move on to the other things.
Maybe they will achieve great things and inspire us. Maybe they'll find out what happened before the Big Bang.
What does it matter?
Maybe they'll determine whether or not the core of Jupiter is hydrogen acting like a metal, or if it's really metal.
And why does that matter to them when they're done?
Because maybe we will discover a new source of energy that will power the whole world based on this new physics.
And why does that matter when they're done?
Because what we do is live. The meaning of life is to live and pass your genes.
The meaning of life is to live, and that's just not an answer that Ken can wrap his mind around. It doesn't appear.
Okay, you live now, pass your genes on, and then you die, you're done. I still don't understand why.
So why would you leave the world worse than you found it?
I mean,
that's my question. Why would you be obsessed with teaching people that humans are not causing climate change? Why would you take a book's word for it when you could discover the world for yourself?
Actually,
that's the mystery to
humans
me.
did cause climate change because we sinned against a holy God, and now we live in a sin-cursed
Okay,
universe.
so, you know, I've spent some time in Japan.
We'll go ahead and pause that there. They stay on this slightly philosophical rant for just a little bit. But the summary is, when you invoke miracles, you're not doing science anymore. You're doing metaphysics or philosophy or theology. There is no difference in science between historical and observational science at the practical level. It is okay if you want to split those into two categories, but at the end of the day, they're from the same root method. They're from the same scientific process. And the issue of inference, how do you infer things from the past and or things that you can't see? This is how science is done. This is absolutely how science is done. Classic example from astronomy. This experiment won a Nobel Prize. Actually, it was more of an observation. Massive bodies in space will give off gravitational waves as they move through space-time. Direct prediction from Albert Einstein in 1916. We found two neutron stars orbiting each other, and their orbit decayed very, very quickly. And the astronomers who mapped out the decay of that orbit, all they saw, they didn't see the gravitational waves. All they saw was that the orbit was decaying, and they calculated how much energy should have been carried away in gravitational waves. They didn't even detect the gravitational waves. And they got the Nobel Prize because what they were able to say is, given these two neutron stars orbiting each other and their masses and the rate at which they're both orbiting each other and the rate at which that orbit is decaying, how fast does general relativity then predict the orbit should decay completely till they spiral into one another? And that's what they were able to track, and that's what they were able to predict. So it was using Einstein's equations to predict something that was then observed. And the inference was, okay, the reason that prediction came true is because the gravitational waves did in fact radiate the energy away, and that's what allowed the orbit to decay. We then find gravitational waves explicitly in 2015, 2016, and that only bolsters the previous observation. But again, we didn't even directly measure the gravitational waves. We just inferred that they were there, and then we're able to confirm their actual existence by direct observation years later, almost 3 decades later, 4 decades later, actually. Same thing with black holes. Black holes had been a theoretical object for a really long time, until the early 90s, and we made direct observations of Cygnus X1. But even then, that was indirect evidence. The observations of Cygnus X1 were observing the effects of the black hole on its environment, and the same thing with the observations of the center of our galaxy. And it wasn't until we got the New Horizons images, not the New Horizons, but the Event Horizons images of the black hole in the center of M87, that we essentially confirmed beyond a shadow of a doubt that black holes existed. So this whole idea that you can't infer things is very bizarre to a practicing scientist, because it's how we do our work. So there's a couple of things that I want to go back and look at. Number one, I want to go back to this claim. We'll go back to that one in just a moment. But this claim by Kent Hovind in the first debate that we looked at Embry-Riddle University, and he makes this claim about the gravitational redshift.
Some people think redshift is for the Doppler effect from stars leaving. Maybe so.
Some people think the redshift is from the Doppler effect of stars leaving. No. Okay. He's talking about the cosmic redshift. Okay. And there's a difference between the cosmic redshift and the Doppler redshift. So the Doppler redshift, okay, the Doppler effect is due to when a source of a wave, whether it's an electromagnetic wave or a sound wave, is in motion relative to whoever is going to be observing those waves, trying to detect those waves. So if I have a sound being emitted from a moving car, and the car is moving toward the right here, toward this individual, this car is emitting a constant sound. Okay, this car is emitting a constant sound, and so the sound waves are going to be emitted from the car at constant intervals. Okay, so you can think of these circles as the crests of waves as they just leave this source. Okay, when when you have a moving car and you move in one direction, if you move in the direction of or let me put it this way, if you move in any direction, because sound moves out in a three-dimensional sense once it leaves its source. If you're moving at that point, you're going to have one direction that is going to move into the crests themselves. So this means as a crest gets emitted and is moving away from you, since you're moving toward it, the next crest that you emit is then going to be closer. And so you have a higher frequency. This individual is going to detect a higher frequency when the car is moving toward them. But if your sound wave, or if your vehicle is moving this way, and you look at a sound wave emitting from back, now you're moving away, and so then the next crest that you emit is going to be stretched out compared to compressed. So in one hand, when things are moving away from you, you're going to see a redshift. Okay, so this is the Doppler effect, and this is what Kent is referring to here. But that's not how the cosmic redshift works. Okay, we're not claiming that galaxies moving away from us, the further they are, the faster they're moving away from us. We're not claiming that the redshift is caused by the Doppler effect due to their velocity. The redshift is caused literally by the stretching of the medium in which the waves are moving, i.e. space-time. If you look at a wave on the surface of a balloon, as you expand that balloon, the wave stretches out. This is observationally essentially the same as your waves being stretched out on this end. Okay, but the difference between the Doppler effect and the cosmic redshift is, in one case, the stretching or compressing is strictly due to the relative motion of one of the objects relative to the observers. The cosmic shift is due to a change in the medium by which the waves are being transported, i.e. space-time. Now, as far as matter is concerned, space-time is a vacuum, right? But it is still stretching, and it is stretching the wavelengths of the background photons along with it. So this is why the background radiation is what we call redshifted, and this is also the source of the redshift of the light of distant galaxies. The light has been traveling through a lot of space-time, and as space-time stretches, it will expand the light. Okay, so now on to an astronomer critiques an astronomer. So I had made this statement about quasars, and I'll let this go for just a few minutes. Mostly the dusty disk of the galaxy, and I don't really see much of the light coming from the jets or the energetic light coming from the accretion disk, because it's all blocked out from by the disk here. If I'm looking at this edge on, then that's going to have a very different luminosity than if the magnetic field is pointed more or less toward Earth and I see the face of the galaxy head on or face on. And in fact, those orders of magnitude in differences of luminosities are going to be on the order of hundreds of billions. Okay, so that's where I need to correct myself. It turns out, after I did a little bit more digging, that apparent luminosities, this is true. We have a range of apparent luminosities on the order of hundreds of millions or billions. Intrinsic luminosities or absolute magnitudes, the most or brightest, and what we mean by absolute magnitudes is if we lined all of them up the same distance from Earth, how bright would they appear? And that ratio is about 60. So from what I've been able to find, so it looks like in terms of how bright they actually are, there's a factor of 60 between the brightest and the dimmest, but how bright they appear to be in the sky is on the order of billions. Okay, but so I was speaking a little bit loosely, and I shouldn't have been, but even if you observe a quasar edge on, you're still going to see a lot of light. It'll just be dimmer than if you see it head on. And the other thing to correct is that you can't have something 100 billion times further away than something else on cosmic scales. The observable universe is only 93 million miles light years across. So I was using the term billions when I was thinking millions, but in any case, I did want to make those corrections after having done just a little bit more digging. Okay, so with that in mind, I'm going to bring this particular episode of An Astronomer Critiques Creation to a close, and I hope that you have enjoyed it, and we will talk to you next time. Take care, everybody.